All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna continue learning how to use Schemdraw. Schemdraw is a Python library that allows you to describe your electrical circuits using Python code, and then you can render them out um, to look like the images that you are seeing at the top of the screen right now. Sorry, I was trying to figure out where you guys would be seeing it. But yeah, we're gonna be continuing learning about Schemdraw. Real quick, I want to make sure that yeah, we're good. I was trying to make sure that we have the right. Well, okay, just for the sake of it being properly aligned, let's shrink it a little more. I don't think it's still properly aligned. Um, well, I shouldn't say properly aligned. I should say not overlapping the window. Um, okay, that became smaller and it did not become bigger after that. Yeah, it didn't become bigger. Hold on. Let me make it bigger and let me see the change show up. Okay. Yeah, I think that's good. Yeah, I think that's good. Okay, so yeah, sorry about that. I got a bit distracted with, you know, resizing that window. But yeah, okay. So we are gonna continue learning about Schemdraw. Um, I have been making a little like first a little bit of a yap sesh. I have been making some good progress with WesTerm, and I'm realizing that WesTerm is one of those um applications that you really have to like explore it, in the sense explore it yourself, learn its inner workings, not exactly inner workings, but like learn about the various tools that are available to you as a user of the terminal, of that specific terminal, and also look for various articles, various discussion threads and stuff. Because what I've found is that there are certain features in the WesTerm terminal that are not necessarily documented in the best way. They are documented, there is documentation on them. It's not the best documentation. Um, it doesn't give adequate amount of information. There tend to be doubts about various things. At least I had doubts, and um, it wasn't until I looked at the discussions section in the WesTerm terminal, in the WesTerm repo. It wasn't until I looked at the discussions section that I realized that there's a bunch of other people who also had these doubts, the same doubts that I had, and a bunch of more doubts as well. Just like me, there were a lot of people who were confused about how workspaces work in WesTerm, what they are, what they do, and so on. A lot of people, just like me, were confused about how multiplexing is handled in WesTerm. And a lot of these people, just like me, were also coming from a TMUX background. So they were trying to replicate that session management system in WesTerm. And WesTerm is capable of doing all of that. It's just that WesTerm does it in its own way, and you have to learn how WesTerm is doing it in order to be able to make a sort of one-to-one version of whatever your workflow was in TMUX. And I believe I can do it. I just need to understand the entire workflow, the way that Western is meant to be used. Because like workspaces, for example, I've understood is that you can have a workspace. Within the workspace, so, okay, hold on. So you can have, let's say you have a window. Within the window, you have tabs, and of course, those tabs will have one or more panes. In my case, it's usually just one pane because I don't have a big enough screen that I would be splitting the panes. But yeah, one tab can have multiple panes, and in that regard itself, you can say WesTerm is a multiplexer because that right there, it's a big part of multiplexing. So you have like multiple shells running within one shell, and then that, or within one process, I guess that the shell is a process. And just like that, you can have multiple tabs running within a process. So these each of these tabs is sort of a container for these panes. Each of these tabs is essentially a shell, and I should look into what happens when it is split. When a pane is split into two, and you now have two shells. What happens to the shell that was within the tab itself? Is it that now this tab is a container for these two shells and there is no third parent shell? It's like how is that situation being handled? I need to look into that. Though I don't really use panes all that much, or split panes rather. I don't really use that function all that much. So I don't need to look into it. Mainly it would be for my curiosity because like I'm trying to understand. Okay, we have the tab, and then the tab hosts at the very least one pane, and within this pane you're going to have a shell running. You can split this pane into two, at which point you now have two panes, and each of those panes is going to be a separate shell, right? So each of them is a separate process. Um, but then like is the tab container itself, the tab that's serving as a container for these panes, does that tab also have like a shell that acts as a parent of some sort? I need to look into that. Or is it that the tab structure is able to manage these two panes and the tab itself doesn't have a shell? It's the pane that has a shell. And when you split the pane, then you don't have a parent pane with two child panes. You have just two panes. It's one pane that you have split into two panes, and now you have two panes, and each of those panes is a separate shell. Anyways, going back to workspaces. So, what I've understood about workspaces is that you can have a window with multiple tabs, and each of those tabs can have multiple panes and stuff. You can make this window a part of so by default it's going to be part of the default workspace. Every window that you create is part of the default workspace. You can set this window to be part of um, another workspace. So you can create a new workspace, and by default, WesTerm will give it like a random name. But through the WesTerm CLI, you can rename the workspace, and you can then set your window to be part of that specific workspace. Wait, no, hold on, hold on. I think I said that wrong. Hold on, because I'm trying to remember my workflow that I'd followed there. Because the workflow that I followed was, okay, so I'll create a new workspace, right? That's an option that you get in Western. You you can create a new workspace, and essentially that opens up that workspace, that loads up that workspace for you. And within that workspace, you have a bunch of these tabs. And like you are no longer in the default workspace at that point. You are now in that workspace that you have created. And you can also rename this workspace if you want. The change will reflect. You have to rename it through the westterm CLI command. Um, but there are plugins as well that I believe do a similar thing. I don't know if the westterm um, I don't know if the westterm like API allows you to do that. So like maybe you can set up key bindings or something for it. I don't know. I'm gonna have to check. But there is the westterm CLI through which you can rename the workspace. Okay, so you have the workspace, right? When you click on create new workspace, a new workspace is created and loaded within that client, within that window, I guess. But I don't think it's window. I think it's I have to discover that. I have to figure out what that like because like okay, you can have sets of tabs that are part that belong to a workspace, but from what I understand, you can also have sets of windows that belong to a workspace. So when you say, load so and so or switch to so and so workspace, I'm assuming that it loads up all of those windows as well. So like I need to see um, how to go about using workspaces. But so far, what I've understood is that you can have a workspace, you can create a workspace. Within that, when you create a new workspace, it's going to load up that workspace within the same Western window that you're currently in. Except you're not going to be in the default workspace anymore. You're going to be in that new workspace that you've created. And you can then because you're in a new workspace and there's a tab by default there, so you can like create as many more tabs as you need or just use that one tab, and whenever you want you can switch back to the other workspace, and these tabs that you've created, they belong to this workspace. So when you switch back to the other workspace, it's going to show those tabs. It's not going to show these tabs anymore. So far this is what I've understood. I'm yet to try attaching to different workspaces from different GUI windows. Another thing I'm yet to try is using the concept of a mux window, because from what I understand, you have like a regular window and you have a mux window, or rather, how do I say this? I don't think I even know what it's called. But yeah, you have the concept of a mux window, and you use this if you want your sessions to persist even after you close the Western window. Because like let's say you've created this new workspace, right? And you're attached to that workspace through this window, this Western window. If you close this Western window and then you try to list out all the tabs and panes and stuff through the Western CLI, it's not going to show that workspace anymore. It's going to show all the other workspaces that you have, but this specific workspace is now gone. So if you do Alt F4 and basically close that window, the workspace gets wiped out. The other workspaces still persist. So this is the part that I'm trying to understand now in Westterm when it comes to multiplexing. There's a lot of experimentation that I have to do, but I'm slowly starting to understand how this works. And like I said, there's a lot of experimentation I'm yet to do to completely understand it. But it's a fairly sophisticated system. And this is why I was mentioning before that there isn't adequate documentation on this. There, there is there is some documentation on the Western website. There's some documentation when it comes to multiplexing and workspaces slash sessions, but the information on those pages, at least to me, it's not adequate. It's not enough for a complete beginner to be able to just pick up all of these concepts very, very easily because, especially if you're coming from something like Tmux, for example, things work a little differently here. Because, like, what I noticed, okay, for example, let's say we open up the WesTerm terminal for the first time. It opens up the window. Um, you have one tab open there, and that one tab has one pane. You don't have to do anything. This is all default behavior, right? And speaking of default, this tab and this window, I'm assuming the window is also part of that workspace thing. Yeah, yeah. Windows are part of the workspace thing. Okay, yeah. Now, considering that Windows, quick side note, like considering that Windows are also part of the workspace, what I'm wondering is, let's say I have multiple windows that have been, I'm yet to set up like multiple windows. Like so far, I've only been dealing with like a single WesTerm client, a single WesTerm GUI window. I need to look into, oh, yeah, that's the other type of window. One is a GUI window, one is a MUX window. And if you want something to persist and you want to be able to use multiplexing and maybe also stuff like attach and detach from wait, sorry. What was I saying? Yeah, I have to look into the difference between GUI window and MUX window because from what I understand, the MUX window is what you would use if you want to be able to persist the session. So even if you close the GUI window, the MUX window itself is still alive. And that MUX window, from my understanding, is the tmux, or it's the WesTerm version of a tmux session. But I could be completely wrong about that. I don't want to like put out wrong information. I'm yet to look into MUX windows. I'm still experimenting with WesTerm. But okay, um, what was I saying about workspaces? I forgot what I was saying. Anyways, I'm exploring WesTerm more. Um, I'm yet to like I'm basically okay. So I've explored a bunch of the other things, but I'm yet to explore fully. I haven't fully explored the concept of workspaces and multiplexing in general. I haven't. I've created. Oh, domains. That's another thing. We have the concept of local domains or a local domain, and then you have SSH domain, and then you have Unix domain. Unix domain is also a multiplexing concept. So if you want something to persist, then you would be using a Unix domain instead of a local domain. I haven't I haven't um, I haven't played around with that too much. So all of these multiplexing related concepts, I need to explore them in WesTerm. But what I do know is that this terminal, it exposes a bunch of very very powerful functionality, let's say, because there's stuff within this terminal that I wouldn't have thought about doing in Tmux. That's not to say that it's impossible to do it in Tmux. Tmux is a very old program. So like it's been around for a while. It's been able to mature for a while. I'm sure it has, a bunch of very useful features for stuff similar to what I'm able to do in WesTerm. I don't know if maybe maybe the Kitty terminal has that as well, and I just never thought about looking too deep into the features of Kitty. Um, but like, dude, WesTerm is it's a pretty sophisticated terminal that gives you a bunch of very powerful features. And I'm glad that I'm looking into the multiplexing side of it because holy shit, dude, I I feel like I'm gonna be able to use these sessions as if I was doing them natively, and that'll be something interesting. Like imagine being able to open up the entire session similar to how like we're doing on Tmux, but then it opens up natively in the tabs within your GUI window. It's opening up as native tabs. You're not attaching to a tmux session, and then within the tmux session you have a bunch of like tmux windows, which is tmux's version of a tab. um, it's not like that. You will be able to open up this. You'll be able to attach to a domain, an ssh domain, and I don't know if workspaces are a part of it, a part of that, or mux windows are a part of that, but you will be able to essentially open up an entire group of tabs natively in your terminal, wherever you're sshing from. So that should be something interesting. Okay, all right. Now, okay, so 20-minute yap session, and now we are going to continue learning about what is it? What is that? What's this thing called? Graph. Um, Westterm. Hold on, I'm trying to. It's not Westterm. It's not Graph either. Schemdraw. There you go. For some reason, I was blanking on the name. Yeah. So yesterday, here's where we left off. We were at this point. Um, Actually, no. Give me a second. Here. Okay. We were. I think we were at the at method, and we tried this out as well yesterday. So we did at for the resistor, and that's how we were able to um, kind of split one resistor's connection into two resistors, or rather connect two resistors to one resistor. And now we are going to carry on with this. So let's read the at method again, and then we can continue. To place an element at a specific location connected to another element, use the at method. For example, to draw an op amp and place a resistor on its output, store the op amp instance to a variable. Then call the at method on the new element, passing the op amp. Oh yeah, okay. So I was about to ask this question. I was about to ask like, okay, where how are we specifying which anchor is getting connected to? But then turns out we are actually specifying the anchor, not just the element. By the way, there's something I kind of realized yesterday. I want to talk about this. Okay, so notice when I hit space, the which key menu pops up on the right side of the screen. There's something like beneath that as well. It's just that what you guys are seeing on stream, that screen is a little bit squashed, so the bottom section of it is missing. But right below where it says split window right below that, there's some instructions mentioning I can hit escape to close like this. I can hit backspace to go back. This is what I'm going to talk about, the back thing. And additionally, I can use Control D to scroll down and Control U to scroll up. So this is to scroll within whatever menu we are currently in. Okay. Here's what I found interesting. When you hit back, it takes you to this menu. I need to look into how this menu is meant to be accessed. But here's the interesting thing. Okay. This menu shows you um, a bunch of key bindings that would be that would do something when you're not in the which key menu. So to access the which key menu, we do this, right? We hit the space key, and this is what we get. You can see in the top left of this which key menu, you can see the key that was pressed to bring it up. Um, okay, so this is what we get with the which key menu, right? But then if we go one step above that by hitting backspace to go back, this now shows us all the possible key bindings that we could be using for various things. So for example, um, what's a good example to give here? So we have go to, right? If I hit G, this gives a bunch of options, and I haven't hit space for this. I just hit the G key. This gives us these options. If I have so this is a fold menu. In addition to, I was about to say additionally, in addition to all of these folding options, it also gives you a spell check option, spelling suggestions if you do have check spelling on. Also, you have stuff like there's a previous and the next. So I was always curious because each time I would find these various keys that I can hit to bring up these different menus, and they don't seem to be connected to the space key in any way. So I was curious about what options do I have when it comes to this, and yeah, it turns out this is how I can discover all the options. I also realized that so okay, you can see these alphabets, right? These are keys that I have to hit. If it's an uppercase character, if it's like a capital character, then I have to do shift and then that key. So for example, if I want to um, invoke the hover function over a function to see its information, then I do shift K. Shift K is uppercase K. So you can see that at the very top of the list. And then there's a bunch of other very useful shortcuts for various things. You can see uppercase H, uppercase L. So that's to, move buffers. I'm used to doing this, previous and then B and then next and then B. So I'm used to this, but like it's not a big deal. Um, Additionally, you have a bunch of options here. Like this is what I'm trying to say is that I discovered that this is what I was looking for when I was trying to find out all the possible like key bindings and like key maps and stuff that don't require me to open up the which key menu, or rather, it's not about not opening the menu. It's about what is possible outside of this menu. Because like technically, if I hit the previous key, it still brings up a which key menu, but for the previous key binding. Um, and then if I hit next, it brings this. If I hit G, it brings up go to. If I hit Z, it brings up a folding thing. And of course, space is also a part of that. So if I go all the way down here, you'll see, where is it? Yeah, down here, all the way at the bottom. Can you guys see it? Yeah, you can. Okay. All the way at the bottom, you can see it says plus 27 key maps. So we have key maps for uh, basically this. These are all the 27 key maps. What does Control P do? Oh, another thing I discovered that I'm glad about is This. So I was not yesterday. For a while, I've been trying to find ways to move lines up and down in NeoVim, and each time I would have to do something like this. Um, but it would be so much simpler if I could just, move the line. And it turns out, yeah, you can with Alt J and Alt K. So yeah, that's another thing that I realized. This on the left side. So if you look at the alphabets that are being displayed on the left side, you'll see an additional key there. I guess you can call it a modifier. You hit that key before hitting whatever the other thing is, whatever the actual key is. So that's kind of a modifier for the actual key. So I discovered that this specific symbol where you see N and P. Oh, you know what? I've never tried this. Hold on. So we have resistor, right? Oh, that's crazy, dude. I've never tried this. Like finding the next reference for this. Usually I would have to do something like um, typing resistor, and then I could use N and P. Oh, don't do that. Then I could use N and why is P not working? What is it supposed to? Oh, sorry. N, uppercase N and lowercase n. Yeah, so then I can do this, but I would have to first search for that, right? Um, Turns out I could just do Alt N and Alt P. So Alt P is gonna go to like the previous one, and Alt N is gonna go to the next one. I wonder if I can do something like that with. Yeah, let's try doing it with something like this. No, I don't think that works. Yeah. I don't think that works because yeah, no, that doesn't work. But yeah, that was dude, that was interesting. Another thing, there's so many interesting things. Like usually if I wanted to do the window stuff, window related activities like splitting the window, for example, I would do space and then W, and that brings this up. Instead of doing that, I could just hit Control W, and then it brings up this menu for me. I don't know if there's something similar for buffers. I haven't checked, like for the buffer which key menu. But yeah, dude, there's like a whole bunch of options here. Oh, I wonder if the oh yeah, that's not there for this. I was gonna check if backslash does something here, because for Lua, backslash has a thing. Backslash allows you to run your Lua code, and it displays the output of all of the entire script within the script itself. That's really interesting. It's more within the buffer, but like it shows the output. Like let's say if you have print statements, it's going to show the output right below those print statements within the buffer itself. So you don't have to open up a separate shell and type in or open up the, well, yeah, you don't have to open up a separate shell and then call Lua and pass in your script to get the output. You can just see what the output is going to be through this. I don't think that's a thing here though. Let me come back here and see if. Okay, yeah, it's not even being mentioned. Okay, then what else? Yeah, okay. So Control C. What is Control C for? Control C is for slime. Okay. Yeah, probably because we have the Python file open. I just realized I'm still yapping. We haven't gotten into, well, we kind of got into it, but then I had to show you guys this thing that I kind of discovered. Um, this thing that I discovered that's going to help me discover other things. That's the interesting thing. Um, okay, okay. Fold, registers, marks, next, previous, and then another marks, and a bunch of other very, very useful options here. I need to scroll through this entire thing. Oh, another interesting one that I found was this. Don't do that. This. Hold on. What did that show? Okay. I'm always nervous to show what's in the. This is for marks. This is not for registers. Okay. Okay. That's fine. You know what? The interesting thing is I rarely use marks. I need to see if there is something that I can do with them, something useful that I can do with them. Um, I'm also noticing the marks have been like pre-assigned. This is different from the other marks that I'd seen. Because in the other marks, you could attach specific labels. I don't know if those are called tags or marks. I think they are called marks. But like you can assign them to specific lines. Um, I didn't have too much use for them because once you have changed your code a little bit, then the marks don't seem to follow. They're fixed to that line, and then at that point the mark is kind of useless for you. Um, so, or maybe it could just be that I missed some feature within marks, because of which I wasn't able to use it to the best of its abilities. But yeah, yeah. Okay. Anyways, let's continue. Right. Then call the at method of the new element passing the op amp dot out anchor. After the resistor is drawn, the current drawing position is moved to the end of the resistor. After the resistor is drawn, the current, okay, it's moved to the end of the resistor. So in this case, I'm guessing R3 is where our line and BJT NPN resistor is going to be drawn. Yeah, we can see that. So RO3 is at the top, RO2 is at the bottom. So to RO3, we have a line attached, and we have the transistor attached at the end of the line. Give me a second here. Okay, all right. So moving on to alignment. Okay, alignment, no, alignment, anchors. Anchors are also used to align new elements with, give me a second. I need to make sure this is not loud. Okay, all right. Okay, so anchors are also used to align new elements with respect to existing elements. Suppose a resistor has just been placed, and now an op amp should be connected to the resistor. Sorry, zoned out. Okay. Suppose a resistor has been placed and now an op amp should be connected to the resistor. The Schemdraw element anchor method tells the drawing which anchor on the op amp should align with the resistor. Which anchor on the op amp should align with the resistor? So this is for situations where you're placing something, um, that has two, because like, okay, the way that I'm looking at this is that you have a before and an after, right? So you have, let's say you've placed a resistor. Um, at the end of this resistor is going to be our after, right? So we then, whatever we place next, let's say it's a capacitor, that gets placed after, right? It gets placed at the end of the resistor. Sorry, zoned out. Yeah, let's say I forgot why I was mentioning that. Okay, all right. The So here the op amp is placed at the end of the resistor connected to the op amps in one anchor. So I guess what I was trying to say is, when we have items that we are placing, when we have an element that we are placing that has two or more input elements, we can call them. Because like in this case, we have R1 that has been placed first, right? And then we are placing the op amp. Let's assume the op amp has an output. I don't know much about op amps. I never really studied that, but I'm gonna assume it has an output. That was in the example here, right? Yeah. So we're gonna assume this has an output, but it has two inputs. It has one output, but it has two inputs. So whenever we are placing this, we have to be able to decide where the connection for we have to be able to decide where the component that we previously came from, where that component is going to be connecting to, because we have two inputs. Now this raises the question, how are we connecting something to the minus side? Oh, I also just noticed that it says in one. So so what I'm saying does hold true there. Uh, this is the input. And I guess the answer here would be, okay, hold on. We can get rid of this and we'll make the circuit long. Okay. Yank and this, and then what is it, 90? No, we want it to be negative 90. Let's just make sure we have this. I actually have slime here, right? Can I not? I'll have to configure slime though. Yeah, I'll have to configure slime. Um, Paragraph send to REPL. It's not the REPL that I wanna. I don't remember because what I had configured slime for, or what I had installed slime for, was to be able to send blocks of code to a Python REPL, an IPython REPL. So that was a whole data science thing. I was doing that for data science stuff. You know what? I'll look into that later on. Basically, what I'm trying to do here is I'm trying to set up a key binding that's gonna make it so I'm able to use the tmux send keys command. Actually, let's try that here. What is this called? I forgot how, wait, just real quick to show you guys what this looks like, what I'm talking about. Um, Remind me how to use um, tmux send keys, um, including including enter. I have two tmux sessions with multiple tmux windows in each. Okay, the tmux send keys command, or send for short. Oh, I didn't know I could just do send. But yeah, okay. Um, for short is incredibly powerful for automating tasks or controlling one window from another. Since you have multiple sessions in Windows, the key is mastering the target pane syntax. Okay, so we had session, window, and pane. The session is called temp rust learning. The window is 13 and the pane is, I'm hoping, 0. I can find out here. Yeah, that's fine. So tmux send keys. Hold on. What if, because I'm noticing that we have the right side of the screen available. What if I split the pane and just send the keys to, but then there's not going to be enough space here. It's going to become very small. Yeah, there's not going to be enough space. I could still try though. Anyways, okay, this is just wasting time. Let's run this. Okay, so we have our line being shown there. Now what we can do is draw a resistor there. So RO4 equals elm dot resistor. Um, do we need to set, I think we need to set a direction, or yeah, a direction here. And then RO5, we do not need that just yet. We're going to do OP01 equals elm dot op amp dot anchor anchor dot anchor n in one. Okay, okay. Wait, I'm realizing something here. This is how we specify what the previous thing should be connected to in this. How are we specifying what the next, how are we specifying, let's say we want to um, connect a resistor going from into, or going from coming from nowhere to into. How are we, how are we connecting to that? Okay, compared to anchoring the op amp at into, okay. To place an element without moving the drawing position. Oh, this might be how we do it. We um use the elements Schemdraw hold position, hold method. The element will be placed without changing the drawing state. The element will be placed without changing the drawing state. So, um, maybe, maybe we could do something like with elm.hold. Is it elm.hold? Oh, wait, we can call the hold method here as well. Hold method prevents position from changing. And then we put a dot there. But then, do we have to also call like a continue kind of thing? So we can do hold self element, do not move the drawing. Here, position after placing, wait, hold on. Oh, maybe, yeah, maybe I should put it down here instead. RO5 equals elm dot resistor um, dot at. No, how would that work? Because we've moved already, right? How does that work? Let's try this. So we have to give it an element. So let's say this. That doesn't work. Cannot be used with width. How are we meant to be using this? Because there was a width, um there was a way to use this width, but like I can't remember what the thing was supposed to be. Um there's a drop method. How did we get to drop? Okay, some elements, especially those with two terminals, do not necessarily leave the drawing position where desired. So after drawing an element, the current drawing position can be set using using the drop method to specify the anchor at which to leave the drawing position, the drawing cursor. Okay, okay. Hold on. I'm trying to figure out. Wait, we're gonna we're gonna do this. Okay. Um, resistor. Um, can I do anchor here? I can do anchor here. Anchor at though. Okay, no, no, that's not gonna work. That's not gonna work. Okay, let's do at this dot into. Okay, so what I was hoping to do here is have something connected to both plus and minus, but then it seems like, okay, maybe this is where the drawing position comes in, right? Um, like we could say hold here, though I don't think it should be hold. How do we place two of these things? No. How do we place two of these things? But then is that where drop would come in? So we place the drawing position at the anchor. No, dude. How are we? How are we setting up two inputs for this? Okay, so this is the whole thing. Oh, it was d dot hold. This maintains a drawing state that includes the current XY position stored in so and so. Okay. Um, Save this drawing position slash direction for later. Go off in another direction temporarily. Oh, this is interesting. So this would be a good way to, like, let's say if we needed to rotate, we could use something like this. So this way we could do something like, wait, real quick. We can say with d dot hold. We can do ro5 equals elm dot resistor dot theta 45. So there's a diagonal, and then we can do another and say ro6 equals elm dot resistor dot theta. This would be negative 45. So we have two resistors now, and then later on, so once we are done with this and we exit, wait, it's holding the position and direction. I just realized that. So what happens when I try to draw um, an RO7 resistor? Oh, um, uh, I was supposed to specify at so and so position. It sets the element XY position. It sets the element XY position. Okay, let's say RO4 dot end, and this one also RO4. Hold on. Dot end. Now let's see. All right. Okay. So hold holds the position. It holds the position and the direction. And once we exit the width block, it resets back to that. Which is why when I created RO7, we now have a third resistor, which is going, straight instead of diagonal. Okay, okay. I'm still trying to figure out. Wait, let me try asking Gemini. Dude, I feel like I could get away with splitting this pane, though I'm gonna have to use this method because I don't remember the it's not window, it's can I go back? No. Um I'm glad that I installed the witch key plugin for Tmux. Okay, split horizontal. I need to give this space. Um, I need to give my left side space, I mean. Um, okay, so let's do this and pane and resize. Um, oh, okay, great, awesome. So I think this should be good. Yeah, I think this should be good. Let's try this. Let's say, actually, what's the thing to switch panes? Wait, okay, let's just, so env bin activate, and then we want to do kitten icat img03.png. That is our image. That's our image. Is it going to become bigger or smaller? I don't think so. Yeah, I don't think it's gonna. Well, I guess we'll find out when I try to increase the size further. Um, Tmux switch panes. Okay. Oh, oh, okay. It's just the arrow keys. So Control B and the arrow keys. Great. Good to know. Um, Resize. Oh, resize is prefix and then control. Okay. Okay, that gets broken up. Let's run that again. Okay. Run that again. Is it smaller? I don't know. Oh yeah, it is smaller. It is smaller. Okay. Let's try making it bigger. Is it just me, or like is there not too much of a difference? I don't think there's too much of a difference. Yeah, I'm kind of confused. I don't I'm not seeing too much of a difference here. Um yeah, dude, I don't know. I can't tell if this is becoming bigger or smaller, but like I'm gonna do this and okay, okay, let's just do that. Oh, and then now here I could do the tmux send keys thing. And is dot a possibility? I think dot is a possibility. Can I just use dot? Okay, to a specific session and window. If you are in session A and want to run ls in the first window of session B. Okay, to a specific so and so, to a specific pane. Can I just use dot? I think I can just use dot. No, wait. What if I want to send it to a pane in the current tmux window? By default, if you don't provide a session or window prefix, send keys looks at the current window to specify. Oh, okay, cool. So send keys t dot one uh, ls enter. Okay. All right. So then what I want to do is Python 3.13 pi01.py. Actually, there's more. And kitten icat img03.png. Done. Okay, there we go. Uh, okay, cool. Oh God, I just realized we are probably on a crazy lag, a crazy delay. I don't know how it took me so long to realize this. Oh my God. Oh, holy shit. We are on a crazy latency, a crazy delay. That is insane. That is so embarrassing. Fuck me, dude. Okay, whatever. I don't know how long I mean, we've been streaming for an hour and 7 minutes now, so maybe it's been going on for a good half an hour so far. Uh yeah, whatever. So this is our image. There is one problem here though. I think maybe I want to clear maybe I want to clear first and then do this. Okay, maybe I shouldn't do the clear thing because each time I do the clear thing, my fans get louder for like a second. Yeah, just this is fine. I need it to be centered though. How do I? Oh, I could throw in a couple of extra enters. Would that work? I spelled enter wrong here. Yeah, let's try that again. Hey, you know what? I'll take it. I'll take it. So this is our image. What what happens if I tack on a couple extra resistors? So let's say this, and then that, and then that. Uh, okay, now has it become smaller? I think now it has become smaller. I think now it has become smaller. So at this point, if I want this to uh, remain at its current width and increase the height instead, then at this point, I should be rotating the direction. So theta, let's say 90, negative 90.0. Yep. Okay. Okay. All right. Um, well, I mean, dude, why am I doing it like this when I could very easily change this command to send the thing there. So we can say temp Rust learning and then window 13, I think. 13. Window 13, pane 0. Yeah, dude. I can just do that. I can just do that. Let's exit this. And yeah, I just realized that because like I am able to look at the other screen and see the circuit diagram. I don't need to do, yeah. It's gonna be a tiny bit smaller, but like, yeah, that's much quicker. That is definitely a lot quicker. Hello, hello, Zaynar. Welcome to the stream. So today, oh, by the way, how's it going? Hello, hello. Today we are learning about the Schemdraw library. This is a Python library for drawing schematics using Python code. So I'm currently just learning how to go about doing various things within this library. And yes, indeed, more breadboards. Actually, that is one of the reasons why I'm looking into this library because I don't like having to open GUI applications for various purposes. Whenever possible, I try to avoid it. And because of that, there's also the fact that I'm much more comfortable with coding something, even coding a drawing, rather than opening up some sort of editor and drawing in the editor. So while there are a bunch of very useful tools, some heavy, some lightweight, for drawing schematics, I prefer to be able to just describe the circuit in this way. And it also makes it easier if I ever wanna if I ever wanna actually, uh, speaking of AI, I would have absolutely asked AI to do it if AI was able to do it accurately. It's just describing it um in terms of regular vocabulary, it can get a little tedious, and also it's you might miss some details when you're describing the entire circuit. At least in this way, I'll be able to describe the circuit properly, and then let's say I want Gemini to analyze the circuit. I can assign the right labels to everything, because like we can have resistors, capacitors, LEDs, voltage sources. I'm assuming we can also have current sources. Um, there's a bunch of different like elements that we can add to it, and we can add labels to all of the elements as well. Once I have a proper image of what the schematic should look like, I can then feed this into, let's say, Gemini, for example, and ask Gemini to um, explain to me how various things are working. Because when it comes to analog electronics, there's still a lot that I have to learn. And some of the more advanced concepts, like um, how to go about sharing ground between two circuits, and how electricity flows when, for example, you split up two connections, sorry, when you split up one connection into two, let's say, it's branching out into like some sort of parallel circuit or something. Those more advanced concepts, I'm not very good at that yet. I still have a lot of I still have a lot to learn in that area. So I'm going to be using Gemini to help me understand these various concepts. And I mean, I've been doing that and it's been really helpful. But like, I'm slowly starting to notice that if I want Gemini to explain how a certain circuit is working, I need to give a proper diagram of that circuit, because Gemini is good at analyzing the images that I'll give to it. So I can then draw out this schematic using Python code and then feed it into Gemini. And Gemini can then explain to me where the current is coming from, where it's going, how it's being split up, how it's getting used, um, if there is a possibility of any sort of electrical noise, how is it going to be, where is it going to be traveling from, and how I can, all sorts of very useful things are possible. Um, So right now, I was just working on a little workflow to like send the command to the other tmux pane, well, the other tmux session, and a window inside that session and a pane inside that window, just so we can display the newly rendered image. Uh, Now, for the sake of keeping things, keeping the circuit simple, I can delete all this and we can continue with. I also don't need the save stuff because I've set up all of I've set up the drawing related parameters here. File name, transparency, the show thing I did just in case if it tries to pop up a GUI window, and then the canvas, which is basically the Matplotlib backend. Um, so we are going to continue with this. Right. So hold. To place an element without moving the drawing position, use the element's hold method. The element will be placed without changing the drawing state. Without changing the drawing state. Okay, so let's take a look at this code. So we have a diode being placed, and there's a dot with the red color, and then we say, okay, that's interesting. There's a move function. There is a move function. No, hold up. We need to go back to the op amp, which I deleted. So I'm gonna set that up again. What was the example gonna be? Um, okay, so here, we're gonna do RO4. RO4 equals elm dot resistor. We do not need any rotations, do we? Okay, there's a move, right? Is there a thing for setting up? So there's hold, there's add, there's draw, get so and so. Here, what is here? The current position, I'm assuming. Interactive, move, pop, push, save, theta. So we can set. Can we set this property? Is that going to work? Let's try elm dot resistor. So we haven't changed the, well, the position has still changed, right? But we have switched the rotation back to what it was. Nope, that didn't work. That did not work. So I'm gonna have to set this manually. Now it works. Yeah, yeah. Okay, let's try also setting the drawing position. So d.move. How are we supposed to give this negative d.unit and -1? What is d.unit? it just says, yeah, no, I'm not sure what d dot unit is. Hold on. We're gonna print a bunch of these things out. So d unit is d dot unit, and then d what do you call it? D theta is d dot theta. I think there's a d position. I think so. No, there was something else to represent the position. What was it? There was a specific here. It was, I think it was here. All right. Um, so what do we get there? So the unit is 3.0. The unit is 3.0. Okay. Um, what if I did this and did this? The unit is still 3.0. Yeah, that's confusing. That is confusing. Um, let's try doing it here. Okay, theta is right. I still don't get what unit is. Okay, wait. Um, d dot unit, negative d dot unit. Actually, didn't I have the drawing thing open here? Let's look at, right. Um, we'll open a new thing and say drawing dot unit. So we have our drawing. Under drawing, we're going to have, these are all functions. Let's go down. Wait, what is all this? Okay, those are parameters, and then these are all the attributes. So there's here, this is the current drawing position. There's theta. There's, what was I looking for? Unit. How do we get to unit? Full length of a two-terminal element. Inner zigzag portion of a resistor is 1.0 unit. So if the inner zigzag portion of a resistor is 1.0, um, judging by the length, or at least what the length looks like, I would say, yeah, that's 3. So then that's why we are going back 1. So we could have precise control over this. And then in this way, we can go one step down. So if we, hold on, let's try something here. D dot move dx equals negative d dot unit. So I'm guessing the unit is whatever was, or the unit value is set by whatever was just drawn. And I'm guessing the height of it doesn't matter. It's mainly the length of it. So then dy equals -1. So that's going to go down, I'm assuming. Um, right. So this should put our, wait, it says negative. Negative is not supported for none. Oh, is it going to work? It works. Okay. This is what I was wondering. Um, and then we move. How do we move the anchor position to, how do we move the anchor position to the end? Let's say we have an op amp. Um, here, okay, we can draw the op amp here down, right? So we can say OP01 equals, because now the position has been set, right? And we are currently on the bottom resistor, so we can draw this to in 2. So elm dot op amp dot, was it at or anchor? I think it was anchor. Anchor in2. Yes, okay, that works. All right. So that fits in perfectly, I'm guessing. Now, what I want to try doing here is placing the op amp first and then moving 1 or 2 steps back. Um, what is the length of this thing gonna be? Can I get the size of the resistor? Because I have the so okay, RO1, um RO1, is it B box? Maybe transform? No, I'm not sure. How do we take a step back? Can we move to, okay, do we have the position for, okay, so we have anchors, right? Anchors, let's say end dot xy. Okay, all right. Um, could we, like, further from this point, like let's say we've drawn um OP01, could we draw at the same position as RO4 and RO5? So we're going to create an RO6. Let's first do D move dx equals RO4 dot anchors, or I can just do anchors dot end. No, RO4 dot end dot x. Would that work? I don't know. I don't know if that's going to work. Then D. Oh, we'll need um we'll need the Y position of RO4 as well. I just realized that because now the Y position of the op amp is between RO4 and RO5. So that's not going to work. RO4 dot end dot Y minus 3 minus 2 minus 2. Right. And then we draw a resistor, and that's it. We don't, yeah, we also don't need the theta here. I should look into like how I would go about, but there's a move drawing position relative to the reference point. I should look into that as well. Um, okay. Theta is a property that we are setting here. There's no function for this though. Config. It's good to know that this exists because I should look into that later on. Container. Add a container to the drawing. Use as a context manager such that elements inside the width are surrounded by so and so. Okay. Draw. Okay, okay, okay. Save, set anchor. Set anchor. Wait, define a drawing anchor at the current drawing position. Wait, no, I'm not sure what that entails exactly. Drawing, set the drawing anchor. Yeah, no, I'm not sure what that means. Okay, all right. So if I have done this right, oh God, okay, that didn't work. Um, oh, maybe because of this. Okay, okay. Yeah, that worked to a certain extent. That worked, but to a certain extent. Um, so we are trying to, can we draw, can we draw at an anchor put? So if we say okay, wait, let's try this. Okay. So then it's drawing at it's moving the drawing position to the anchor and it's going to start drawing from there. The drawing is not happening in two directions. For some reason, I was assuming it's happening in two directions. And so I would have to place the anchor to the center of where the resistor is supposed to be, um, or to the center, to what would be the center of the resistor later on after it's drawn. But no, I have to set the anchor, I have to set the position to uh, the place where the drawing is going to begin, and then the entire resistor will be drawn from that point on. Okay, all right. Now, um, why do we seem to have this issue? Oh, um, could it be because of this? So center. Center is also an anchor, isn't it? Center is an anchor. Center is an anchor. Um, what happens if I draw at center? I think that's going to mess it up because then it's going to start drawing the resistor at that point. Actually, something different than what I was assuming would happen happened. Hold up, we moved the drawing position up there, and then we tried to move it. Sorry, zoned out. Okay, all right. So, um, what does drop do? Some elements, especially those with more than two terminals, do not necessarily leave the drawing position where desired. So after drawing an element, the current drawing position can be set using the drop method to specify the anchor at which to leave the draw. Okay, I think this is what I was looking for. I think this is what I was looking for. Let's try something here. Um, so we're gonna say d dot, is it d? No, ro4 dot drop. Set the drop position where to leave the current drawing position after placing this element. So we're gonna set the drop to be, it has to be an anchor, right? So we're gonna set it at the start of ro4. And then we want, where are we trying to move? We're not trying to move this. Yeah, so we can set that to 0. We are trying to move this though. So we'll set this to -2. Now, does that work? No, that didn't work. What if I did this? That moved it further away. Hold on. I'm curious about something. What are the anchors for the op amp? So let's do op01 dot anchors. Um, so we have out, in1, in2, vd, vs, n1, n2. There's no start and end here. I was wondering if there's a start and end, and that might be causing an issue here because maybe drawing is currently maintaining um, a state. Actually, I'm curious about that as well. Is drawing currently, so we've drawn resistor, right? Does drawing have an anchors thing? What is drawing holding? Nothing. Drawing is not holding anything right now. All right. If I, let's say I set it like this. So that's as good as just not doing ro4.drop, because drop doesn't seem to be, well, dropping there. Am I getting this right? Am I getting the anchors thing? There's an I start, I end, and then start and end. Okay, the start position for ro4 is -1. That's interesting. It's -1. Hold up. Um, so yeah, no, I'm getting kind of confused with this. You know what? I'm gonna continue with what's being taught here. Maybe the problem that I'm trying to solve will get solved later on. For now, we're gonna continue with this. For the time being, we got this thing solved. What we were trying to do, drawing at two different, you know, terminals. But like I'm still, I want to solve that other problem as well. I guess I can look into that off stream. For now though, we need to do this, the hold method. So we're gonna delete all of this. Um, we have our resistors. Okay. All right. So elm dot diode and then elm dot dot color red. Okay. So DO1 equals elm dot diode dot theta. Let's set the rotation to 0. And then we do elm dot 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 color red. Okay, then we do d dot move dx equals, oh, and then we draw a second diode below that. We draw a second diode below that, and then we hold the, okay, now I get it. We did not change the drawing position. So the drawing position, it starts here at whatever the start point is, and then it draws the thing, and then that's the new drawing position now. So that's why when we did the dot thing, it drew over here, and I'm guessing the drawing position doesn't change much with dot because it's not very long or long at all. And then we move the position back and down 1 unit. Sorry, we move it back 1 unit, which in this case is 3, and down by -1, essentially changing the position to be down here, right? So it's back and then down. Great. Then we do diode dot hold. So it draws the diode, but then it also holds the position. So it doesn't actually change the position of the cursor where it's going to be drawing from. It doesn't change that position. And because of that, when we do dot color, then it draws the thing here. Okay, that's interesting. So Is there a way to connect a component that we have drawn directly to an anchor? Because like I know that we can draw at a certain anchor, and that is going to be. Yeah, yeah, sorry, for a second I paused there because I was like, okay, we are drawing at the anchor, but then how does the at function know which elements anchor to draw at? And then I remembered that we do element dot anchor. It's not just a string that we are passing in. Okay, all right. Um, yeah, let's draw this. So we're gonna do negative d dot unit, not unity. I'm so used to typing unity from like years of unity work, years of unity experience. Um, so DO2 equals elm dot diode dot hold, and then we do another elm dot dot color blue. All right, okay, that did exactly what it was supposed to do. All right, okay. I am curious about something I'd seen here though. So under drawing, we have um oh, interesting. Okay, so this is the context manager related stuff. So I was also looking at config. So we're gonna do d.config. Oh, am I gonna have to specify everything myself? This is a function. Okay, I'm hoping that the thing doesn't require me to specify every single, argument. Um, Inches per unit, font size. I mainly came here for the size related stuff. Full length of a two terminal element. Okay, never mind this. Let's continue with this. So we've done the hold method, which that's great. Now we know how to set that up. Um, Actually, this would be a good way to, because like what I'm wondering is, let's say we have two separate circuits that we are designing, but like we have to draw them at different sections and then eventually have them join into let's say an op amp, for example. How are we going about doing that? Because we are able to set. So okay, move. What is move doing? It moves the current drawing position. Okay, dx, so change in position. So that's relative to where we are now. And then what does move from do? It moves the drawing position relative to the reference point. Change drawing theta if provided. Relative to a certain point. What is the point supposed to be? The point is supposed to be, I think, just a position, right? So then if we specify, like, um, let's say we specify, so d dot move from reference point, what is this, ro2 dot, what was it, position, xy, scale x, um, how are we getting the position? Oh, that's how we're getting it. So I'm guessing it's going to be so if, let's say I specify, um, start, so then that's our point, right? Dx equals, actually all of that is fine, right? And then let's say I draw another dot. Let's make it a green dot. So elm dot color, hold on, dot color, green. I don't know if that worked. Hold on. Yeah, I see a green dot there. That worked. So we can move it relative to, okay, okay. So this way, with move from, um, I can specify a certain anchor point, and using the dx and dy attributes or arguments, I would be able to specify an offset from there. So I could say, for example, dx equals, I don't know, 1.0. And then now we can see the green dot slightly, to the side. Now it's not at the junction. Now we can actually see the green dot. Um, okay, okay. We learned something. Hell yeah. Then, drop. Some elements, especially those with so and so, do not necessarily leave the drawing position where desired. So after drawing an element, the current drawing position, yeah, we should check this as well. In fact, yeah, hold up. I was, wait, hold up. I kind of tried to combine hold up and hold on, but yeah, hold up. D dot move from. Let's do a drop instead. Oh, we can only drop. where no, yeah, where are we? Okay, leave the cursor on the emitter after placing the BJT. So this is more for like output stuff. And maybe that is why RO4, which does not exist. I previously tried to do RO4 dot drop. Maybe that's why that didn't work, because the element has already been placed, hasn't it? Oh, this also returns an element. This is, yeah, okay, okay. You know what? Maybe that was the reason. So let's try something else here. We have dot. At this dot, we're going to draw how, what's a good, what's a good like example to use here? Oh, okay. We can try this. So we do RO4 equals elm dot resistor dot um drop start. Yeah, yeah. We can do elm dot resistor dot drop dot start, and we can make this theta zero, no, not zero, 45. And then we do this and this. And we don't need to drop here, but we do need to rotate this in the other direction. So if I've understood this correctly, um, we should be drawing RO4 and RO5 at the green dot, and they're gonna have like a V kind of thing going on. No, that did not happen. Oh, that didn't happen because, yeah, yeah, no, I get why that didn't happen. Um, no, I don't get why that didn't happen. No, 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 hold on. Can we only specify ends? What if I do I start? I don't know what I start is supposed to be, but let's try that. Yeah, that didn't work either. Um, yeah, no. This is not, drop is not doing what I thought it would. Also, what's interesting is the green dot, the green dot seems to have moved for some reason. Oh, no, 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 the green dot didn't move. We were supposed to be up here. Was it this? Oh, there. So we move and then we draw a green dot and then now let's try it. Yeah, okay. The green dot is back where it's supposed to be. It drew the first resistor, RO4, but then it tried to draw RO5 where RO4 ends. So that's not what we want. Yeah, no. I'm doing something wrong here. I'm missing something here because this seems to work for um a BJT. Hold on. Some elements, especially so and so, do not necessarily leave the drawing position. So does this work only? And they mentioned two terminals here. So I'm wondering if they're only counting the two output terminals, and that's why drop only seems to work on the output terminal, or what would be considered the output terminal. But I don't see how that would apply here because it's not two outputs, it's one output, and it's two inputs technically, because you have the gate and you have the, or I guess the base. I forgot what all the terms are, but like you have this is the emitter. No, this is the emitter. This I believe is called the base. I've forgotten what the oh, yeah, collector, base, emitter. So this is where you give the signal. This is where your current is coming from. This is where it's going. And when there's no signal here, then current is not going to flow through this. Because of which the circuit will be open. And so when you give some signal here, then the current will flow through this. Why am I explaining this? Uh, collector, base, emitter. So this is the collector. We did not mention collector. BJT2. Uh, okay, okay. In BJT2, we have specified that yeah, this is supposed to be a BJT NPN drop emitter. So the next drawing position comes here. Is it that drop only seems to work for things that have 2 points, two like output anchors? Yeah, I'm not sure. I'm not sure. I'm gonna have to experiment with this more. But I'm gonna continue reading up on this. Um, maybe I'm gonna continue reading more on this after stream, or I might just go back to doing Wes term stuff because there's a bunch of exploration that I have to do in Wes term as well. Bunch of experimentation I have to do. So we can probably continue this tomorrow. I don't think I'm gonna raid anyone today. I'm just gonna end the stream and grab something to eat and then come back and continue with this because I have a lot of work to do. I need to switch to Western like soon, like real quick, because this is taking way too long and I'm kind of in between Western and Kitty and well, Kitty plus T-Mux. And I don't want to just leave it at that. Otherwise, I'm just never going to be using Western unless I'm able to, completely move over. And for the most part, I'm loving everything about Western, so I don't want to kind of, you know, abandon Western. It's a pretty decent uh, terminal. It's great. The configuration is done in Lua. I've gotten a hang of the configuration. I've gotten a hang of how to install plugins, how to customize it to my own liking. And now I'm learning about multiplexing in it, multiplexing workspaces and session management and stuff like that. There's a lot for me to explore there. So yeah, you know what? I don't think I'm going to continue with the Schemdraw stuff off stream. I'm going to continue in tomorrow's stream. Um, yeah, yeah, yeah. So that's going to be it for today's stream. Zanar, thank you very much for stopping by and hanging out and chatting. Anyone else who might have been lurking, thanks for hanging out. Um, yeah, yeah. I'm gonna stream again tomorrow. I'm gonna try and start earlier than today. Though today, I mean, I did manage to stream for 2 hours, so that's great. That's awesome. That's what I'm usually aiming for. 2 to 2.5 hours. So yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you